Question 19. Silicon carbide has a similar structure to diamond. Boron nitride has a similar structure to graphite. However, boron nitride does not contain any delocalized electrons. Bronze is an alloy of copper and tin. Which statement is true? So in order to answer this question, we need to take a look at what the structures of these three substances are. We have silicon carbide, we have boron nitride, and we have, over here, bronze. So first of all, silicon carbide has a structure similar to diamond, which means that it is a giant covalent structure. And the bonding is similar to diamond, which means that it will have the same tetrahedral structure, where each atom is bound to 4 others. And we expect it to have a high melting and boiling point. Why? Because it takes a lot of energy to break these covalent bonds. And we expect it to be a non-conductor of electricity, because there's no free electrons to carry a charge, and it will also be very hard, just like diamond. Why? Because it is very difficult to force the atoms out of place. Okay, next let's look at boron nitride. Boron nitride has a similar structure to graphite. However, it does not contain any delocalized electrons. So this actually tells us that boron nitride will be a non-conductor of electricity. But other than that, it will have properties that are very similar to graphite. So that means that boron nitride has a giant covalent structure. So it will be similar to graphite in that you have the hexagonal structure, except you don't have any free electrons. So you have your different layers, and they will be attracted to each other by weak intermolecular forces of attraction. So if we look something like that. So there are strong covalent bonds within layers, but weak intermolecular force of attraction between the layers. So the properties we expect it to have, it will have a high melting and boiling point. It will be a non-conductor because, again, it doesn't have any delocalized electrons, and it will be quite soft and slippery, just like graphite. Why? Because the layers are easy to displace using a force. Then what about bronze? Bronze is an alloy of copper and tin, which means that this is actually a mixture, and it is held together by metallic bonding. So the structure, because it's an alloy, we will have basically copper and tin positive ions or cations, and they will be of different sizes. And they are surrounded by a sea of delocalized electrons. Yeah, so this is the metallic bonding. So what are the physical properties we expect from it? Well, it will have a high melting and boiling point, because the electrostatic force of attraction between the positive ions and the delocalized electrons is quite strong. It needs a lot of energy to overcome. It will be a conductor of electricity because it has delocalized electrons, and we expect it to be quite hard. And it's less malleable than, let's say, pure copper, pure metal, because it has different sizes of ions, so the layers are not as easy to slide over each other. So now let's answer the question. Let's look at our options. A, all three substances are covalently bonded. This is not true because bronze does not have covalent bonds, but metallic bonds. B, all three substances have high melting points. Yes, this is true because both silicon carbide and boron nitride are giant covalent structures, and they have high melting and boiling points, whereas bronze, being held together by metallic bonding, will also have high melting and boiling point. So we expect B to be True. What about C? Bronze and silicon carbide conduct electricity. Okay, bronze can definitely conduct electricity. Why? Because it has these delocalized electrons. But silicon carbide will not be able to conduct electricity because there are no mobile charge carriers. So how do I know this? Silicon and carbon are both in group 4 or 14. Which means that in order to create this structure, tetrahedral structure with each atom being bound to 4 others, it will have to use up all its valence electrons. So there are no free electrons to be delocalized, hence there are no mobile charge carriers. All right, then let's look at D. Silicon carbide can be used as a lubricant, but boron nitride can be used as a drill tip for cutting. Okay, this is actually the other way around. Silicon carbide cannot be used as a lubricant because it is too hard. Whereas boron nitride cannot be used as a drill tip for cutting because it is too soft. It's actually the other way around. So the correct answer to this question is option B. And here it is.